Good day, students. Welcome to the study of organic chemistry. In Uniben, it is called Chem 124, and in DSU, it is also actually called another course code. And different universities in different places or countries or states calls it with different course code, but it's actually the same topic or the same chemistry that we are treating. Don't forget, this is exquisite tutorials, and I am Dr. Best. Now, today, we're looking at the last tutor that talked to us organic chemistry, Chem 124, was Dr. Austin, and when he was teaching, he introduced us to the study of alcohol, and there he talked about how alcohols are formed, replacing the hydrogen from alkene and replacing it with hydroxy, turning methanol to from methane to methanol and the rest. He told us about the properties of alcohols, and he told us so many things about alcohols. Today, we are still going to be looking into alcohols. And today, I want us to start by looking into the sources of alcohols. Sources of alcohols. Now, when we talk about the sources of something, we are talking about the means or ways in which these things can be gotten. So, when we talk about the sources of alcohols, we are talking about how alcohols can be gotten. So here, first of all, let's talk about the natural sources. Natural sources of alcohol. Now, naturally, alcohols are gotten from several ways. You know, when we are talking about what actually makes alcohols, remember, is the presence of hydroxy group, which is responsible for hydrogen bonding, and which also makes alcohol to be soluble in water. Now, note first of all, before we look into the natural sources of alcohol, generally, hydrocarbons are insoluble in water, but alcohols are soluble in water. The reason why alcohols are soluble in water is the presence of this hydroxy group, which is responsible for hydrogen bonding, which actually makes alcohol to bond in water. You know, the bonding in water is hydrogen bonding. So this hydroxy group makes alcohol to be soluble in water. Now, let's go back to the natural sources of alcohol. One of the main natural sources of alcohol is sugars, or we can say carbohydrates. Now we have so many carbohydrates. We have the ribose, the oxyribose, the arabinos, and the rest of them. So the one major natural source of alcohol is sugars. Number two, we have amino acids. Amino, as we may call it, amino acid. Number three, we also have cholesterol, that what we call steroids. Steroids are actually one of the natural sources of alcohol. And four, we have plant pigments. Which is to say, alcohols can be gotten from your plant pigments. Now, let's ask a question. Let me ask you a question. Okay, let's say one of the following, okay, let me use my words. One of the following is not a natural source of alcohol. One of the following is not a natural source of alcohol. And I will have number one, ribose. Number two, we'll have HCl, which is an acid. Number three, we have cholesterol. And number four, we'll have, let's say, amino acid. Now, which of these is not a natural source of alcohol? Remember what we told you, sugar, carbohydrates. Ribose is a sugar. Number two is amino acid. And we'll come here, we'll see HCl. HCl is not a sugar, it's not an amino acid, it's not a steroid, it's not a plant pigment. So definitely, HCl is not a natural source of alcohol. Cholesterol is a steroid. Amino acid is a natural source of alcohol. So these are some of the natural sources of alcohol. Then from there, let's talk about synthesis. Synthesis. Now, when we are talking about synthesis, we are talking about ways in which alcohols can be gotten apart from the natural ways. We can what the things that we can put together to give us alcohol. When we talk about the synthesis, can actually be commercial or industrial ways of getting alcohol. Now let's take one way of getting alcohol is a process of reacting esters with base. Let's say sodium hydroxide, through a process known as saponification. Saponification is a process whereby esters react with base. Let's say, for example, sodium hydroxide to give you alcohol. So this is one of the syntheses or commercial ways of getting alcohol. And another way of getting alcohol too is the hydration of ethene. Hydration of ethene. Hydration of ethene. Now, when we talk about the word or alkene, actually hydration of alkene, because ethene is an example of alkene. Let's say, e.g., ethene. Hydration of alkene. Now, when we talk about hydration, we are talking about addition of water to a substance. So when water is being added to an alkene in the presence of an acid, let's say, for example, in the presence of H2SO4 as a catalyst. What you get, the end product you're going to get is an alcohol to produce an alcohol. So these are actually some of the syntheses of alcohols. Another one is fermentation. Now let's talk about fermentation. Fermentation of sugar. Now remember, when we are talking about the natural sources of alcohol, we made us to understand that alcohols are getting from sugars or carbohydrates. Now, in fermentation process, this is what happens. The fermentation process is a process whereby sugars are converted to alcohols through a process of some chemical reactions. Now, what acts as a major, the substance that acts as a major importance in the fermentation reaction is yeast. Note this. Yeast is the microorganism that acts majorly, is one of the most important organisms that acts on sugar during the fermentation reaction. What does yeast do? What yeast does is, yeast produces mattase, gives us mattase, enzymes. And these two are catalysts which are responsible, who plays a major role in the fermentation of sugar to give us alcohol. Now, let me give you how this reaction. First of all, it starts with starch. Let's say this is your starch. C6, this is your starch, H11O5. So let's say N. In the presence of diates, as a catalyst, gives you maltose. Maltose is C12H22O11. This is your starch, and this is your maltose. Now, from maltose, your C12H22O11, in the presence of maltase as a catalyst, gives glucose C6H12O6. This is your maltose, and this is your glucose. Now, glucose in the presence of zymase as a catalyst, C6H12O, I'm coming, C6H12O6, in the presence of zymase as a catalyst, gives you alcohol, which is C2H5OH plus CO2. So this is how the fermentation of sugar works to give you an alcohol. Remember, we talked about the saponification of esters, hydration of alkene, and fermentation of sugar. Now, from now, we are going to look into two major or two vital alcohols, and we are going to be looking at methane and ethane, methanol, with the formula CH3OH. Now, first of all, we're going to be talking about methanol. We are going to talk about how methanol has gotten from preparation of methanol, the uses of methanol, and some properties of methanol. Now, first of all, methanol, there is another name of methanol. Then I will show you how that name came about. Methanol is called methanol or methyl spirit. Or wood spirits. Now, we are interested about the wood spirit. Now, the reason why methanol is called the wood spirit is because of one of the industrial preparation of methanol. Methanol is gotten from preparation from the destructive distillation of wood. Now, this is the reason why methanol is known as wood spirit, because it's gotten from the destructive distillation of wood. Another way of where methanol can be gotten is a reaction between hydrogen and carbon monoxide in the presence of chromium trioxide or chromium zinc to give methanol. Reaction of hydrogen with carbon monoxide in the presence of chromium trioxide or zinc. Now from here, let's talk about the properties of methanol. Properties. This is very interesting. Now, number one thing that you should know about methanol is that methanol is a poisonous gas. So methanol should not be consumed. do not consume methanol unless you want to commit suicide. But please do not commit suicide. Now, methanol is poisonous. And there's a special thing I want you to know about methanol, which is number 2. Apart from the fact that methanol is poisonous, methanol causes immediate blindness if consumed. Causes immediate blindness. When consumed. So now, there are 2 occasions where you should only permitted to take ethanol. Methanol, sorry. One is if you want to commit suicide, or if you want to cause yourself blindness. But please, do not cause yourself blindness. Now, number 3, properties of methanol. Now, all alcohols have almost the same chemical and physical properties. But in terms of just like methanol and ethanol, but there's a difference between them. Now, I will tell you the major difference between methanol and ethanol. Now, let me tell you one. One is that methanol is poisonous, just like I told you, but ethanol is not poisonous. But before we get to ethanol, methanol has a boiling point of 67 degrees Celsius. It boils at 67 degrees Celsius. This is another property of methanol. And number 4, we say methanol can be used as a solvent. This is actually part of the using. Okay, it's a solvent actually. A solvent. Now, from here, I want us to look into the uses of methanol. I'm going to be telling you 3 major uses of methanol. One is that methanol is used as a solvent. Used as a solvent. I will explain. 2, as an antifreeze. As an antifreeze. 3, used as fuel. Now, first of all, we're talking about methanol being used as a solvent. Methanol is actually used as a solvent in so many chemical or industrial processes. Just like your ink, the pen you use to write, methanol can be used as a solvent for ink. It can as well be used as a solvent for dyes. And as well, methanol can be used in your pharmaceutical companies in the production or manufacture of some drugs like your vitamins and an antibiotic known as streptomycin. Now let's talk about the number 2 use of methanol as an antifreeze. Now, when we talk about an antifreeze, what's an antifreeze? An antifreeze are substances or liquid or solvents that are used to maintain or regulate the temperature of a solvent. Now let's say, for example, your car. Okay, let's say let's use for example your car. You are traveling for a very far distance and you are going to travel for like 10 hours. The work of your antifreeze, almost every car has antifreeze that is being put on it. The work of your antifreeze is to maintain the temperature of your engine as at that time that you are traveling. Now, as you are going, the temperature is becoming hotter. The work of the antifreeze is to make sure that the temperature does not become overhot, leading to evaporation, or in the time of cold, the temperature does not become, it maintains the temperature from being frozen. Now, methanol, how methanol works as an antifreeze, that methanol reduces your melting point. Reduce melting and increase These are the two ways that methanol works an antifreeze. It reduces your melting point so that your let's say your solvent or your liquid will not easily reach the melting point, and increases the boiling point so that in time of heat it will not easily reach the boiling point. Now the third one is used as fuel. Methanol is used as fuel in so many engines or so many cars or boats. Now there's another work that methanol does in fuel. Your gasoline, when you add methanol to your gasoline, addition of methanol plus gasoline is going to give you now addition of methanol to your gasoline yields increase in volatility. It's going to give you a more volatile fuel than your normal gasoline. Now from this, let's talk about ethanol. Your ethanol is C2H5OH. Now, your ethanol is the most useful alcohol. That is why most times your ethanol is regarded as alcohol. Your ethanol is actually regarded as alcohol because it is the most useful alcohol. Now, talking about the properties of your ethanol has a boiling point. Boils at 78 degrees Celsius. They can say 78.5. And your ethanol is actually also used as an antifreeze and so many things. Now let's talk about preparation of ethanol. One major way of preparing ethanol is your fermentation reaction. Preparation. Now we'll talk about fermentation when we are talking about synthesis of alcohols. The major way of getting your ethanol is fermentation of sugar. Fermentation is a major way of getting your ethanol. Your ethanol can as well be gotten just like every other alcohol from the hydration of an alkene, especially an ethene, to give you ethanol. Now let's talk about the uses of ethanol. Uses. Now, just like every other alcohol, like I told you, your ethanol is one of the most, or I can say the most useful alcohol. That is why it's regarded as alcohol, or you can call it ethyl alcohol. Now, let me explain something to you. You discover that when you take beers or alcoholic drinks or wine, it is intoxicating. It makes you stagger. It has a way of working in your brain, affecting your balance, the part of the brain which is responsible for balance, which is the cerebellum. Now, what is responsible for that, of that intoxicating effect, is the ethanol. Ethanol is responsible for the intoxicating effects on beers and wines. So notice, what is responsible for that intoxicating effect in your beers is your ethanol. Without the ethanol, your alcoholic drinks wouldn't have been intoxicating, and it cannot be called alcoholic drink when there is no alcohol inside, and the alcohol inside is the ethanol. Now another thing about the ethanol is that unlike our methanol, we said our methanol is poisonous, ethanol is consumable. Ethanol is actually consumable. That is why you can drink ethanol and not die. You can consume ethanol and not go blind. Now, another thing about ethanol is that ethanol can as well, just like methanol, be used as antifreeze. Antifreeze, and is as well used as solvent. Ethanol can be used as solvent in many companies, pharmaceutical industries, and the rest. Now, before I proceed, the last thing I'm going to talk about is the reaction of alcohols. But before I proceed, I want to ask us a question. Let's say, for example, Wallace, the faculty rep of BMS, University of Benin, brought out 3 liquids, and he said one of this liquid, he wants to identify this liquid. Maybe he's asking sources, the course coordinator of microbiology in Delta State University, and was like, this 3 liquid, one contains one of these liquid, or let's say the one at the center is a liquid which is poisonous and as well causes blindness when consumed and has a boiling point of 67 degrees Celsius and is a solvent. Now, what comes to your mind? That is a methanol. Your answer should be a methanol. Or let's say when Wallace comes up and he said, I have 3 liquid, but I do not know the name. But one of the liquid is one of the solvent has a boiling point of 78%, 78 degrees Celsius. It is consumable and has a pale blue and brings out a pale blue color pigment when oxidized with high oxygen. Now, one of the property of ethanol during combustion with oxygen or combustion with fire, ethanol produces a pale blue coloration. Note this. So by the time when Wallace comes in and said one of these substance or one of these solvents has a boiling point of 78 degrees Celsius, on combustion produces a pale blue pigment, and as well it is consumable, what comes to your mind? It is ethanol. So you can be able to differentiate between ethanol and methanol. Now from here, let's talk about the reactions of alcohols in general. Let's talk about the reaction of alcohols. The reaction of alcohols. Now, alcohols undergo some major reactions. And note, in your exams, or most especially for university students, most questions regarding alcohol always comes out from the reaction of alcohols. The first one is what we call esterification. Now, esterification reaction is a reaction whereby alcohols react with carboxylic acid in the presence of H2SO4 as a catalyst to give esters. That's what we call esterification. Now, when we're talking about the synthesis of alcohols, we talked about saponification, a reaction whereby esters react with base, where we use sodium hydroxide as an example to give us an alcohol. So esterification is the opposite reaction of saponification. So this is a reaction whereby alcohols react with carboxylic acid to give esters. Okay, let's say this is your alcohol, ROH, plus your carboxylic acid, RCOOH. This will give esters, RCOOR. Now, the second reaction. Okay, let's talk about reaction with metals. Reaction with metals. Alcohols react with more electropositive metals. Let's say, for example, sodium and potassium, giving up hydrogen. So alcohols react with metals, or let's say more electropositive metals, to give out hydrogen. So they react with metals to give out or give off hydrogen gas. Number 3, let's talk about the oxidation reaction. Alcohols are oxidized to give carboxylic compounds. We'll talk about carboxylic compounds. We are talking about the aldehyde, the ketones, and the esters. Now, the oxidation reaction of alcohols is dependent on the type of alcohols, the primary, the secondary, and the tertiary. When primary alcohols, or let's take from here, primary alcohols are oxidized to aldehyde. Secondary alcohols are oxidized to ketones, while tertiary alcohols do not undergo oxidation. The tertiary alcohols, they do not oxidize under normal conditions, but on high temperature and on a high concentration of the acid, that is where the tertiary alcohols can be oxidized. But normally, they do not oxidize under normal conditions. Now, the fourth reaction that we're going to talk about is the dehydration. Now, just like when we were talking about the synthesis of alcohols, we talked about dehydration of ethene to give us alcohol. The hydration, like I told you, is the addition of water. Now, when these alcohols are dehydrated, which is the removal of water, it gives you ethene back, or let's say alkene. Now we're talking about alcohols. So dehydration reaction to give an alkene. This is a major reaction of alcohol, the dehydration reaction of alcohol to give alkene. So this will be the end of today's class. In our next topic or next videos, we'll be talking about phenols and other carboxylic compounds and the rest. Don't forget, this is Exquisite Tutorials. Subscribe to our YouTube channel. Drop your answers or questions on the comment section, and they'll be attended to as soon as possible. Thank you. Love you.